So I'm going to give an overview of our platform, KGNN Knowledge Graph Neural Network, and I'll talk a little bit about how it relates to Power 10, and I'll step away in the middle of the presentation to do a little bit of a demonstration, show you guys some of the capabilities just to give a feel for what KGNN delivers, and then hopefully we can move on to a discussion about how to apply this. So here's the agenda. I'm going to talk about data challenges first. That's kind of the justification for why KGNN exists. We're going to talk about knowledge graphs a little bit. I'm going to explain what that is conceptually, which acts as sort of a primer for why KGNN is a capability that we should look at for delivery. And then we'll talk about KGNN itself. We'll talk about what it is. We'll talk about how it's architected just at a high level. We're not going to go super deep on that. And then we'll discuss what makes it different, why KGNN is special in the market. And then we'll do a little bit of a demonstration, and then we can come back and look at the Power 10 application of KGNN. So let's get into it. So data challenges. The main justifications for KGNN's existence are twofold. It really comes from organizations having disparate data problems. So we know this. Like our background is defense focused, and when we're working with defense organizations, we continuously saw that organizations would have a bunch of different databases with different types of data, different schemas across different networks, different levels of access, and this created a lot of challenges for decision makers. So the first sort of area, the justification for KGNN, is decision support across disparate data. And then the other area, which has become more relevant recently, is supporting AI solutions. So AI models, especially these like large language models and the like, are very expensive and time consuming to train. And that makes building a model that can have a sort of current and up-to-date picture of an organization's data expensive. And generally, it's just something that organizations can't support. So what KGNN, part of the justification for KGNN is to help support these AI solutions so that we can get up-to-date and improving results from our AI models without having to perform model retraining. Ultimately, the way we see this connecting to business needs, of course, is that companies and organizations of all sorts really care about revenue. They care about cost mitigation. They care about risk mitigation. And all the things we have on the screen here are major business risks that KGNN can help to mitigate. Let's talk a little bit about knowledge graphs. So a knowledge graph is just a way of representing data. What makes it compelling is really its flexibility, the ability to represent data from a huge range of different domains seamlessly and in the same database, as it were, without having to build complicated domain-specific schemas for every data representation. A knowledge graph itself consists of vertices, which are also called nodes. That would be these sort of little bubbles here, which represent concepts. Those concepts could be concrete or abstract. And those vertices are connected by edges, which are also called links or relationships. And those links communicate semantic information about how these things are connected. So a dog is an animal is a living thing, a cow is also an animal. But notice here that plants and animals aren't one another, but they're both living things. We can encode all sorts of information in this way. You can encode, as you'll see with KGNN, the information in a news article or a CSV document or something like that. Used widely already. Knowledge graphs are already used widely in science and healthcare, doing pharmaceutical research, and in finance, if you're doing anti-money laundering or something like that. The real challenge with knowledge graphs, as it were, is that they're difficult to build. So from a database representation perspective, they're very straightforward to build because you don't need a database schema like you would with an RDBMS context. But they're difficult to build because you need traditionally some sort of pipeline to take some data source and structure it as a knowledge graph. And those are time consuming and expensive to build. And I'm going to talk a bit about how KGNN solves that problem. So let's get into what KGNN is. KGNN stands for Knowledge Graph Neural Network. And I call it a data unification platform that comes in two parts. The first part of that data unification platform is an AI-driven automated data mapping layer where Equitus has developed our own in-house AI models, architected those models into pipelines that can take in data from just about any source and extract semantically rich knowledge graphs from that data. And then we combine that data mapping layer with what I call a multimodal semantic layer. So the semantic layer is actually the thing that handles the storage and the querying, the making available of that knowledge graph data once it's been derived by those AI models. We combine those two things together. I'll talk more about this, but that's one of the things that makes KGNN pretty unique. We integrate data from countless sources. Another thing that's really important about us is the open architecture. So I will, again, talk more about this later, but we use industry standards for communication over the network. We try to make our system as ergonomic as possible so that we can integrate both on the data ingestion side easily and on the data exploitation side, which I'll talk a little more about here in a second. So here's KGNN, the architecture at a simple level. You kind of read this diagram left to right, and it highlights how data flow works. On the left side of this diagram, we have how I'm representing data sources. So we've got external databases that could be, like an Oracle database, for instance. We've got data feeds. You could think of that as like IoT devices, could be live data feeds or historic data feeds or Kafka topics or something like that. Unstructured repositories, think like an Amazon S3 bucket, could have any kind of unstructured data inside of it. Or for some applications of KGNN, it might be user-facing, right? And in those user-facing applications, we could support file uploads directly from users. We do support file uploads from users. For most of this data, it flows through what we see here on the left side, these ingest plugins. Ingest plugins are very simple, I call them structural adapters to outside data sources. So they handle things like authentication and submitting queries to those outside databases. They don't do any of the hard work of understanding what that data means. All of those data artifacts flow through our ingest controller, which handles submitting that data to an appropriate ingest pipeline. And the ingest pipeline is really where Equitus has a lot of our intellectual property. We have a handful of ingest pipelines for different types of data. And the ingest pipelines are responsible for finding people, places, things, events, the relationships between those things, and then performing both co-referencing and disambiguation, which basically means looking within the document and outside the document to see, are any of these concepts that we're finding duplicitous? Are we seeing the same person mentioned twice in one document? Hey, does this person or this event, do these things already pre-exist in our knowledge graph, or are these new concepts? Once that knowledge graph has been created by one of these ingest pipelines, we pass it off to what I call here our core services. This kind of abstracts away our microservice architecture. But ultimately, the knowledge graphs get stored in an RDF triple store down here. Other kinds of data that don't belong in a knowledge graph, say video and imagery or spatiotemporal data, get stored in one of these domain-specific stores. And then it becomes a question of how do you want to exploit the data? And there's a bunch of ways we can approach that. So we have up here analytic plugins. So KGNN includes a handful of analytics out of the box that are designed to be highly general. They're designed to apply to any knowledge graph data. And that's useful. A lot of people will find those effective. But also we know that sometimes customers will need domain-specific analytics based on the kinds of data that they work with. And we could work with the customer or with a third-party vendor, a system integrator, for instance, to develop those analytic plugins to get after the answers that users want for their data. We can also integrate through what we call a connector plugin. So a connector plugin is a two-way adapter that allows read and write access to the databases within KGNN. And it can be used to integrate things like data science tools. So if we wanted to have a Jupyter Notebook integration for data scientists, user interfaces. So, imagine it's like a BI tool, Power BI or Cognos, for instance, or large language model integration. So if we wanted to deliver a conversational interface to a customer's data, we do that through the connector plugin, which can, again, it can support, Sparkle queries, or it can support something along the lines of those vector queries, or we want to do, similarity scores or something like that. A lot of flexibility there. We also deliver a user interface, which is kind of focused on intelligence analysis, free of charge with the KGNN platform that we call Fusion. Some of the demonstrations I'm going to do today are going to be in Fusion. So you'll get to see a little bit of that. Some customers will find Fusion highly applicable for the use cases, others will not, and that's just fine either way to us because it's always delivered with KGNN. And then finally, we have this export plugin situation. So for some integrations as part of larger architectures, a customer may just want to use KGNN as a piece of a pipeline, right? So this entire thing, this entire architecture here in green and in blue kind of becomes a data ingestion pipeline for some other system of record. And if that's the case, then we can use these export plugins. They're sort of a unidirectional, one-way data flow out of KGNN and into some other more authoritative database, depending on the customer's needs. So that's architecture at a high level. Now I'm gonna kind of go through some of these differentiators. Why is this different? So the first thing is among semantic layer products, of which if you go to a trade show, you'll see many of them. Semantic layer products usually rely on a data engineering approach to create their knowledge graphs. So what that means is the vendor delivers an empty knowledge graph system, and then they sell FTEs to their customers where they'll build bespoke data pipelines to ingest their data. That can yield really good results. We're not knocking that approach. It's difficult because it's difficult to scale. So already it can be quite expensive because you need a lot of subject matter experts, and usually the vendor is billing those at a high rate. But then if the customer has this need for to ramp up their data ingestion needs, ramping that up can be very difficult to do quickly because you need to source personnel and train them in order to get them able to do that data ingestion. KGNN takes a different approach. We build these AI models to do really the full suite of data ingestion tasks, so that when a customer wants to do a large scale data ingestion, there is no, the only constraint on the scale of their data ingestion is computing resources. If they can apply more computing resources, they can ingest more, they can ingest faster. And in addition to that, KGNN can be configured to operate either in a fully automated fashion for organizations that have they don't have a lot of personnel available, or in a human in the loop sort of mode where humans can comment on and correct the outputs of the AI models. Just depends on how the organization balances that sort of data integrity need versus the cost effectiveness of operating the system. But we can support both. Another thing that's quite compelling about us is the default global ontology. So most of the time when these semantic layer products are delivered, they're delivered empty. And when I say empty, what I mean is they have nothing in them. They don't have any commonly known facts or organizations, people, anything like that. And usually the burden rests on the customer to do that development, to integrate data so that the semantic layer has enough information in it that it's above a sort of critical mass. And what we've done to sort of sidestep that is we've integrated a very large knowledge graph data set out of the box, so that when we deploy KGNN, on day one, there's already about 100 million people, places, things, events, and relationships between and among them. I'll show you guys a little bit more of that later. But that makes a big difference in terms of how long between deployment, how much of a gap there is between deployment and the actionable usefulness for solving some business problem for a customer. Another thing we talk about is scalability. So we've integrated scalable technologies top to bottom in the KGNN platform. Some of them are listed on the right-hand side. We deploy the entire stack inside of Kubernetes, and that matters for a few reasons. One is for scaling up. So we have the ability to scale up basically to any size for big data ingestion and for servicing queries from, say, large user bases or from high frequency automated systems. A system like this is always going to be beholden to the amount of computing resources it has available. But one thing that makes KGNN a little bit different from some other technologies is we've also put work into making KGNN scale down. And what that means is we want to be able to deliver a reasonable level of data ingestion and data analysis and query servicing capabilities, even on very minimal hardware. I call this the graceful degradation of capability. You should have the ability to make use of the system, even when it's operating on relatively minimal hardware. And that really increases our flexibility when it comes to servicing customers. Some customers will have need for large enterprise-grade systems. Other customers want to be able to make use of their data, even on very small systems or on network disconnected systems or something like that. We can support the full range of use cases there from a scale perspective. Fundamentally secure. So our background is in US DoD sales and engineering. So we have had to work around some of the most stringent software security constraints that exist in the world. And in order to meet those needs, we've integrated what we call fact level security. So that means every individual statement we make about a person, every single statement we make about a person, place, or thing, those statements are all individually have different access control applied to them, or can have different access control applied to them. So if we have a person, John Doe, we could make it so that that person's birthday, for instance, is accessible to everybody who uses the system, but that maybe that person's last known location is highly restricted and only a select family of users can get access to it. We also have role-based and attribute-based access control. We use Keycloak to integrate with third-party identity providers. So for instance, we can integrate with Active Directory. We've done that in the past, and that allows us to inherit a customer's own access control rules into the way that we control access to data. We've also got a minimal vulnerability footprint. This is to do with deployment on classified networks inside the United States. But what we've had to do is to develop both processes as well as things like CI/CD pipelines to eliminate software vulnerabilities from our stack. And those processes and pipelines don't just provide a sort of one-time instantaneous benefit, but on an ongoing basis, they allow us to identify early and mitigate quickly new software vulnerabilities, because they're always being discovered. New ones are always being discovered. And we know that that's a critical risk mitigation for many customers. Finally, open architecture. So KGNN, we see it as a full service solution. It's highly usable for a suite of use cases where you wouldn't really need anything else except the pre-existing data and then some sort of exploitation tool. But KGNN can be integrated as part of a broader data architecture with many other systems and capabilities if needed, if that's what the customer is looking for. And we actually have experience doing that, integrating inside of a modular open systems approach architecture. So that's a real benefit. There's a lot of vendors in this space who they're looking for vendor lock, they're looking for walled gardens, and that's not been the Equitus approach. All right, so what I'm going to do, I'm going to pivot over real quick. Just going to sort of show a little bit of the Fusion user interface. First, I'm going to start here. Oh, whoops, I'm not sharing my screen. Give me a second here. Stop sharing and share again. All right, can you guys see my screen?
Yeah, we can.
Yep. Great. So this is one of our this is our user interface, and again, this is just one avenue for doing data exploitation in KGNN. I'm going to show you some of the capabilities that we provide. So the first thing is we have this concept of what's called a project. A project is a sort of window into the larger knowledge graph. In KGNN, we really are working on curating one massive knowledge graph that represents an entire organization's data. So in order to provide a little bit more ergonomics to accessing such a massive data set, we can produce these projects which allow a user or a system that's making use of KGNN to narrow its focus, and also to do things like controlling access. So if we make one of these projects with a certain level of security constraints around it, we can prevent more secure data from entering a project that's less secure, as it were. Then I go in here, I click into one of these projects that I've created, And we can see a few things. One is the ability to control user access. So making sure that different users of the system have different levels of access to this data. I can constrain who can manipulate the data inside my project. We have here the activity feed. Activity feed is a really fundamental aspect of how KGNN operates. We're able to basically allow systems, or in this case, a user interface, to subscribe to changes that are made to a data artifact. In this case, that data artifact is the project itself. This could be really useful if you wanted to, do alerting or something along those lines, because we can provide this context-sensitive feed of data. And then finally, what I'll do is I'll show some of the real data analysis features. So on the right-hand side, what I did is I went ahead and ingested the Wikipedia article for IBM, and you can see that as we scroll through here, our machine learning models have extracted all these different concepts, people, places, things, relationships from this Wikipedia article. But what I wanted to really highlight here is not just the extraction that's taken place. And I should highlight, of course, the colors here all correspond to ontological types. If I pull this up, we can actually, 1 second. If I go over here and I pull up a histogram, we'll see a breakdown here in a second after this loads. Yeah, here we go. So we can see there's a color coordinated breakdown of how all these colors relate to different concepts that have been pulled out of this document. In this case, we've picked out 1,248 different tags, but those have been collapsed into a smaller number of entities because many of these entities are referred to multiple times in the document. But we don't just have the ability to do this data extraction from, say, an unstructured data artifact like this, but we can combine that with our massive default knowledge graph. So if I go in here and I click on this IBM node, we can see we already know a lot of information about IBM, right? We know some other names that the company is known as. We know their description. We have a long list of properties, connecting IBM to other concepts. You can start to zoom out here and see how IBM connects to a huge family of different concepts. So let's kind of break this down a little bit with a histogram. We can see there's lots of people in here, different people who are relevant to IBM for whatever reason, right? So board member, we see a board member here. We see another person over here. The key thing here is that some of these concepts were found in this document, and some of them weren't. They just pre-existed within the system on day one, and that's true for so many widely known concepts. If we want to get a different visual perspective on this data, we have lots of options there. So maybe I wanted to do a sequential layout. Now I can see, I can get a different view of this data, which gives me some perspective on important concepts, right? So I can see some of these people really stand out as highly connected. I can see this organization over here, IBM, obviously. IBM is what I started the knowledge graph based on. You can see connected to all these different concepts. Any one of these concepts that I might have interest in, right? Maybe the jQuery Foundation, pull that up. I can get a little bit of data about the jQuery Foundation, right? I can go over here. Maybe I want to look at this place. This is a city, Armonk, New York. Well, that gives us another perspective. So I'll go ahead and change some of the layout elements of this. Let's do a structural layout. And now let's take a different view of this data. We'll do over here, where's the view on map, right? I'll close this. And now we can see a geospatial representation of that same data. So many of the objects on this map have locations in space that we can go look at and get a picture of. We can zoom in here. Maybe I want to see this. Show me this on the graph. Takes me right to it, so I can get some perspective of what that data is like. Of course, the reason I'm showing all this isn't just to show off how great this user interface is, although I think we're pretty proud of it. The reason we're showing this is that every one of these features and functionalities that I click a button and it does a thing, those features and functionalities are supported on the back end by KGNN, can be exploited by, again, data scientists or users on a dashboard or a large language model that's trying to give you a conversational interface for your data. So I'm going to go ahead and
Ashwin's got a question.
Oh, sure, Ashwin. What can I do for you?
Sorry, just a quick question. So a lot of this information is coming from your pre-baked ontology, correct?
That's true, yeah.
And if that needs to be customized, is that something that you do within this, add in new ontological elements, change some elements. Is that possible?
Absolutely, yeah. So we have a handful of approaches for how we can solve that. So one of them we call aliasing. So aliasing is where maybe an organization likes the way we're representing data, but they don't like the terminology we use. Aliasing is kind of an overlay where we can change what things are called based on an organization's needs. That's something we've seen a lot in the DoD space. Another option is ontological subclassing. And so that's where maybe our ontology goes to a certain level of depth in one area, like cars, but you want a higher level of depth because you work in the automotive industry. We can either find or build a subclass ontology which fits into the broader ontology while still allowing us to do ontological inference across disparate concepts.